This is the Algebra 1 Summer School Unit 5 Mixed Factoring Practice. This is one of many files of mixed practice. What this is going to have is I'm going to do numbers 1 and 2 from the first section, number 5, 6, and 7 from the second section, and 13 and 14 from the third section of this page. All answers have a key posted on Canvas, and if you need other questions or have other questions and need them answered, please come see your instructor during office hours. So the first portion here, number 1 and 2, say to factor the polynomials using the greatest common factor. So we need to look for a greatest common factor, or GCF. When I do that, I'm going to look between the 5x squared and the 10x. Well, it appears that 5 and 10 both have a 5 in common, and also the x squared is 2 x's. They have at least one x in common. So I'm going to divide both terms by our GCF of 5x. When I divide by 5x, I'm left with just x from the first term. 10x divided by 5x is 2. That's your answer, 5x times x plus 2. If you wanted to check, you could distribute 5x to both terms. 5x times x is 5x squared. 5x times 2 is 10x. That's what you started with, so you know that you got the right answer. Number 2, factor by GCF. Here's a lot of terms, so we're going to take it one step at a time. Between 2 and 6, I have a GCF of 2. Between x cubed, which is 3 x's, and x squared of 2, I have 2 x's in common, x squared. And there's a y, one y, in each term. So my GCF is 2x squared y. I'm going to go ahead and divide each term by 2x squared y. When I do that, 2 divided by 2 is 1. X cubed divided by x squared is x. Y divided by y is 1. So I'm only left with an x in the first term. From the second term, 6 divided by 2 is 3. X squared divided by x squared is 1. X divided by, or y divided by y is 1. So I really only have 2x squared y times x plus 3. That is the final answer. Now moving on to our next couple problems. Factor the polynomials of the form ax squared plus bx plus c. All of these terms in 5, 6, and 7 are trinomials. They're trinomials because they have 3 terms. When I factor a trinomial, I use a method called split the middle. There are lots of factoring methods, but we are going to teach you split the middle. When I start this, I look at the number in front of x squared. Here it's 1. I'm going to take that 1 and multiply it by the last number, 8. So I get 1 times 8 is 8. I need to find 2 terms that multiply to 8 and add to 6. Those turn out to be 2 and 4. 2 times 4 is 8. 2 plus 4 is 6. Now, in order to split the middle, I bring the first term down, which is x squared. I also bring the last term of 8 down. I then split up the middle with 2x and 4x. That's what adds to be 6x. Well, once I have those split into 4, I group. I put the first 2 terms in a group and the last 2 terms in a group. Now I look for a GCF for each group. The GCF for the first pair is an x. So I write an x out in front, and I divide it away from both terms. That leaves me in the parentheses x plus 2. Now for the second group, because this 4 is a positive, my GCF is going to be positive. It's going to be positive 4, because 4 and 8 both have a 4. So I pull out a 4, and I'm left with x plus 2. Now recall that my goal is for the 2 terms in the parenthesis to be exactly the same. That means that you factored correctly. I then can pull down this x and the 4 as one term and the x plus 2 as the other factor. Just as we did above, if you want to check your work, you can distribute. right, let's try number 6. Just like the first problem, there's an invisible 1 in front of the x squared. So I need to multiply 1 and negative 48 and find two numbers that multiply to negative 48 and add to negative 2. This can be a little harder if you don't know your multiplication tables, but our numbers turn out to be negative 8 and 6. I'm going to split the middle now and bring down the x squared and the negative 48 and fill in the middle with the negative 8x and the positive 6x. Once I do that, I'm now going to do my grouping, where I find the GCF. The GCF between x squared and negative 8x is x. So when I divide by x, I'm left with x minus 8. In my second group, because this term is positive, my GCF is positive, it's going to be positive 6. So I'm going to divide both terms by positive 6, which leaves me with x minus 8 in the second parentheses. As usual, I really like that because x minus 8 shows up twice. This allows me to write my final answer. The x plus 6 goes in one parenthesis, and the x minus 8 goes in the other set. And that gives me my final factored form. All right, last but not least, number 7 for split the middle. I always start by multiplying the first number, this case of 4, by the last number of negative 12. Okay. But wait, hold on. I noticed something here. I should have noticed this before. When I multiply 4 and negative 12, I'm going to get negative 48, which is okay. Negative 48 isn't that big of a number. But we don't always like big numbers to have to multiply to. And we should always remember that the first thing you do every time you factor something is look for a GCF. Well, in this problem, it appears that there is a GCF, and that GCF is 4. When I divide every term by 4, I'm left with x squared plus 2x minus 3. Well, even though I have that GCF out front, that's okay because now I'm going to do split the middle just on this inside part, which is actually going to be a lot easier because 1 times negative 3 is negative 3. Two numbers that multiply to negative 3 and add to 2 are 3 and negative 1. So when I split the middle just for this inside part, I'll deal with the 4 later. I have x squared plus 3x minus 1x minus 3. When I look for a GCF for these groups, I have x for the first one, which leaves me with x plus 3. And because this term here is negative, my GCF is negative 1, which gives me, again, x plus 3. Negative 3 divided by a negative is a positive. Well, to write your final factored form, you take the x minus 1 times x plus 3, but you can't forget that we started with this 4 out in front. So I have to put that other GCF of 4 out in front, which then gives me a final factored form of 4 times x minus 1 times x plus 3. And that one's a little bit more involved, but it's nice to see one that's a little bit more challenging. All right, lastly on this practice, I'm going to look at number 13 and 14, the factoring for the difference of two squares. Difference of two squares, we have to notice a couple things going on in these problems. First, you have to have a binomial. A binomial has two terms. There has to be a minus sign. Okay? So when I look at these problems, there's two minus signs. That's where the difference of squares comes from. And then thirdly, I have to be able to take the square root of each term. When I look at 13, I can take the square root of x squared and the square root of 4. That gives me x and 2. Once I have x and 2, since I had a binomial with subtraction, I can write my factored form as x plus 2, x minus 2. All right, let's, just like every other problem that we've done on this video, let's double check that this works by distributing. I'm going to take x times x, which is x squared, x times negative 2 minus 2x, plus 2x minus 4. Notice here that the negative 2x and the positive 2x cancel off, and you're left with x squared minus 4. That's what I started with, so I know I factored correctly. Last problem for the video. I determined it's a binomial, and it has subtraction. Now I have to check on the square root part. It turns out that I cannot take the square root of 5. So I actually, and I can't take the square root of 125. So I have to do what I always look for first, a GCF. It turns out that this problem has a GCF of 5. So when I divide both terms by 5, I'm left with x squared minus 25. But that's actually a good thing, because now I can take the square root of x squared, which is x, and the square root of 25, which is 5. So between that x and the 5, I bring down my GCF, and I get my fully factored form of x plus 5 times x minus 5. Okay. All right, if you have other questions on that mixed factoring practice review, look at the answer key that's posted on Canvas. Try the other mixed practice that are on the same module on Canvas, or come into office hours and ask your instructor for help.